Hello everyone, I'm Shivani and welcome to Civil Series. Here I come with one more video of BMC practice question, which is part 3, and in the part 1 and 2 we discuss the question from BMC from a technical part, and this is the next video. First question: the maximum stress that can be applied to a material for an infinite number of cycles of repeated stress without causing failure is called as. For infinite number of cycles without causing failure is called as endurance limit. Endurance limit जैसे ही और एक टर्म होती है उसे कहते हैं fatigue, but fatigue is with specified number of cycle and endurance limit is with the infinite number of cycles. So option D is correct here. So option D is correct here, but option A, B, C, both the three terms are also important. So let's discuss the remaining options here. So this is the chart, or this is the graph of stress strain curve or stress strain graph. Here stress is nothing but the internally applied force with respect to particular cross sectional area, and strain is nothing but a change in a length to original length or change in a cross section to original cross section. Okay, so on the x-axis there is an independent variable is mentioned, which is strain, and on the y-axis there is a dependent variable is mentioned, which is stress. Stress is in Newton per mm square and strain is unitless. Okay, so this graph is related to mild steel. अब ये ग्राफ माइल्ड स्टील के लिए हमने बनाया है, तो इस ग्राफ में बहुत सारे पॉइंट है A, B, C dash, C, D, E and F. Okay, so point A is known as limit of proportionality or proportionality limit, which is the point in which stress is directly proportional to strain, and that point is beyond which linear variation is ceases. After the point limit of proportionality, the linear variation is ceases, but up to point A, stress is directly proportional to strain, and up to that point Hooke's law is valid. Hooke's law is nothing but the stress is equals to E into strain. That E is the Young's modulus, and stress is directly proportional to strain, and to equate the stress and strain there is a constant which is called as Young's modulus or modulus of elasticity, which is represented by E symbol and unit is Newton per mm square. Then next point is B, which is elastic limit. Elastic limit is the maximum stress in which original length regain. Okay, means up to point A and B, the original length or original whatever the shape of the mild steel is regained up to the point B, up to the elastic limit. So that's why the region from y-axis to point B is the elastic region, and up to this point we can regain the original shape or original length by removal of loading. Then next point is C dash. C dash is the upper yielding point. So yielding point is nothing but the point in which the material get deformed or material started to get deformed. Okay, that point is nothing but a yielding point, and C point is the upper yield point, means here the stress is maximum. Okay, in the C dash the stress is maximum as compared to C, which is lower yield point. Okay, and that upper yield point, the magnitude of stress is depend upon the cross section and the shape of specimen. Lower yield point, in that point yielding is also happen, but the stress is less as compared to C dash, means upper yield point, and that lower yield point is the actual yield point. Then after C, point D is formed, and the distance between C and D is perfectly plastic region. C and D, the region is perfectly plastic region. In that region, stress is constant, strain is increasing. Okay, plastic strain here is 10 to 15 times of elastic strain. Then after D, the point E is rises, between D to E, that line, here in the D to E, the stress is increasing, and that region is strain hardening. In that, strain is also increasing and stress is also increasing. And then next is E point, which is ultimate stress point, and the ultimate stress point is the maximum point of a stress, and the strain here is 20% of mild steel. Then after E, the point F is rises, which is fracture point, and the region between E and F is necking region, and in the necking region the cross section is drastically decreases. In that necking region, stress reduces with respect to strain. Then last point is fracture point, and that fracture point is nothing but a breaking point also, and the stress about that point is a breaking stress, and strain about that point is the fracture strain. Then the strain is 25% of mild steel. The strain, whatever the strain is present here in the fracture point, is 25% of mild steel. And from B to F, that region is called as plastic region. So this is all about the stress strain curve or stress strain graph, and all the points are important from this graph. Proportionality limit, A is the proportionality limit, B is the elastic limit, C dash is the upper yield point, C is the lower yield point, C to D is the perfectly plastic region, D to E is strain hardening zone, E is the ultimate stress point, E to F is the necking region, and F is the fracture point. Then second question, fixed end movements at A and B for the fixed beam shown in the figure subjected to indicated uniformly varying load are respectively. अब इस डायग्राम में एक फिक्स्ड बीम गिवन है और इस फिक्स्ड बीम पर एक यूनिफॉर्मली डिस्ट्रीब्यूटेड लोड गिवन है. Okay, so there are different conditions of fixed end movements with different loadings. So let's discuss the conditions one by one first. So first condition is fixed beam is in both condition the common thing is fixed beam, but the loading is point loading is at its center here in first condition, and in second condition the point loading is eccentrically applied here. So the fixed end moment for MAB and MBA, MAB is for first end or A end, and MBA is for B. So the movement at first end is negative because it is anti-clockwise, and at the second end is positive because this is clockwise. So remember, first column is negative and second column is positive. If the point loading is applied centrally, then the fixed end moment is minus WL by 8, and at B plus WL by 8. Then second, if point load is applied eccentrically, if we want to calculate the end moment at A, then take a square of B, and if you want to calculate the moment at B, then take a square of A. Okay, so here minus WAB square for A divided by L square, and second WBA square by L square. Simply यहाँ पर अगर आपको A सपोर्ट पर मूवमेंट निकालना है तो B का स्क्वायर लेना है, और B पर निकालनी है तो A का स्क्वायर लेना है. ठीक है, so this is the fixed end movement for point loads at its center and at eccentric region. Then second condition is with uniformly distributed load. So for uniformly distributed load, first condition minus WL square by 12, or for first end movement or at A point minus WL square by 12, and for second WL square by 12 plus WL square by 12. So this is most asked. This is the uniformly distributed load at mid region. So this is the formula for the MFAB. So that MFAB is minus WA square divided by 12L square in bracket 6L square minus 8LA plus 3A square. Then second for MBA plus WA cube divided by 12L square into 4L minus 3A. Then next condition, this is the fixed beam with uniformly distributed load for whole span, and that fixed end moment at MAB is minus WL square by 30 and for MBA is WL square by 20. Then this is the uniformly distributed load for mid region. Here this is A and remaining portion is L minus A. So this is the formula for MAB and this is the fixed end moment for MBA. Then if uniformly varying load is in triangular position for whole span, then MAB is minus 5 divided by 96 WL square, and then second MBA plus 5 divided by 96 into WL square. Then last condition, in the last condition, fixed end movements or fixed beam with the movement at center, and here the movement is with the eccentric distance. So the movement for MAB is m by 4 and for MBA is m by 4, here plus and plus on both sides. And for this movement also MB in bracket 3A minus L divided by L square, and for second MBA, MA is equals to 3B minus 1 divided by L square. So these are the conditions for fixed end moments. Then question second is fixed end moment for this uniformly distributed load. So as we see before, the fixed end moment for this uniformly varying load fixed beam is minus WL square by 30, or and for B plus WL square by 20. Then question third, the maximum slenderness ratio for a steel tension member is. For a steel tension member is. So this is the chart for slenderness ratio. Slenderness ratio is the ratio of effective length to radius of gyration. So the first condition or the type of member, a member in which reversal of stress due to the load other than wind or seismic forces occur. Other than wind or seismic forces, then maximum slenderness ratio is 180. Then second condition, a member acting as tie in a roof truss or a bracing system subjected to possible reversal of stresses due to wind or earthquake forces. The maximum slenderness ratio is 350. Then third condition, the tension members other than pretensioned. The tension members other than pretensioned are 400. Then here they ask steel tension member, the maximum slenderness ratio is 400. Option C is correct. Then fourth question, the effective length of compression member shown in the figure is equal to. So there are different conditions related to effective length. So the effective length here for this, first the end is below end, or the first end is restraint for translation and rotation, and the upper end is restraint for rotation and free for translation. Then the effective length is 1.2L. So this is the effective length chart of remaining condition, and if you want a video related to the effective length, there is one video on my channel that how to remember this effective length chart easily, and I think you should watch that video, and you can watch that video from my channel, or else I will put the link into the I section or in description. Then next question, the thickness of battens shall not be less than shall not be less than 1/50 of the distance between the innermost connecting lines of rivets, bolts or welds. Here option B is correct, and this is the important question. So the 1/50th of the distance between the innermost connecting lines of rivets, bolts or welds. This is the thickness of battens that shall not be less than 1/50th. Then next question, the thickness of T of a single flat lacing should not be less than 1/40th length between the inner end rivet, and for double flat 1/60th. This is also important. For a single lacing, T should not be less than 1/40th, and for double lacing, T should not be less than 1/60th. Option B is correct. Then the bond produced in a brick masonry by laying alternate headers and stretchers in each course is called as Flemish bond. In the Flemish bond there is alternate stretchers and headers. Okay, but the Flemish bond is divided into two types. First one is single Flemish bond, second one is double Flemish bond. In single Flemish bond, the front side is having the alternate headers and stretchers, and in the double Flemish bond, both sides has alternate headers and stretchers. So the proper answer of this question is double Flemish bond, but here they ask alternate stretchers and headers in each course. So the answer is double Flemish bond. Then these are the remaining bonds. First is stretcher bond. Here all the cores are formed by stretchers. Second, header bond. All the courses are formed with headers in front. And then this is the Flemish bond. Flemish is with single Flemish and double Flemish. Here the alternate headers and stretchers in each course. कोर्स मीन्स दिस लाइन. ओके, कोर्स क्या होता है? कोर्स मतलब अगर ये ब्रिक का लेयर हम यहाँ पे लगा रहे हैं, ये जो हॉरिजॉन्टल लाइन है, इस हॉरिजॉन्टल लाइन को हम क्या कहते हैं? कोर्स. और इस कोर्स में अगर सारे स्ट्रेचर्स हो तो ये होता है स्ट्रेचर बॉन्ड. अगर इस कोर्स में सारे हेडर्स हो तो वो होता है हेडर बॉन्ड. अगर इस कोर्स में एक स्ट्रेचर है, एक हेडर है, एक स्ट्रेचर है, एक हेडर है, तब इसे कहते हैं हम फ्लेमिश बॉन्ड. और इंग्लिश बॉन्ड क्या होता है कि जो ये कोर्स है, इस कोर्स में ये पूरा कोर्स हेडर्स का है, उसके बाद जो कोर्स आएगा वो पूरा स्ट्रेचर्स का है, उसके बाद जो कोर्स आएगा वो पूरा हेडर्स का है, उसके बाद जो कोर्स आएगा वो पूरा स्ट्रेचर्स का है. अगर ऐसे कोर्स आएंगे तो उसे कहते हैं हम इंग्लिश बॉन्ड. सो फ्लेमिश एंड इंग्लिश बॉन्ड बोथ आर द important condition and both are mostly used conditions. So these are the cuts of bricks which is used in the bond of bricks. So first is a full brick, second this is the half bat. If we cut it half by its length, then this is 3/4 bat, this is beveled bat, queen closure, king closure, this is beveled closure, and this is mid-rate closure. So these are the cuts provided in the bond of bricks. So these all are important. So remember this. Then next, which of the following is true for project evaluation and review technique? PERT. PERT is project evaluation and review technique, which is true. Okay, so first of all, PERT is the event oriented. Okay, PERT is event oriented. CPM is critical path method, which is activity oriented. PERT is event oriented and CPM, critical path method, is activity oriented. Then second, PERT is a tool for planning. Then third, their time estimate are need. Fourth, based on probabilistic approach. And CPM is based on deterministic approach. Then fifth, cost is directly proportional time, hence minimum cost will be achieved. to minimum completion of time. Sixth, suitable for a new type of project which not happened earlier. So here option A is correct because this is true about the project evaluation and review technique. It is event oriented and is a tool for planning. Option A is correct. Then next question, question number 9. In the stability of floating bodies, the stable equilibrium is attained if the metacenter M point dash the center of gravity. Dash the center of gravity means lies above, coincide with, is parallel to, or lies below. Before discussing the answer, let's discuss the condition of floating bodies and stability of submerged bodies first, or what is the metacenter and buoyancy point and center of gravity. So first, metacenter. Metacenter is the point about which a body start oscillating, when the body is tilted by some angle. If body is tilted by some angle, then body start oscillating. That point is metacenter, and it is the point where the line of action of buoyancy will meet the normal axis of the body when the body is given a smaller angular displacement. Okay. Then stability of floating bodies. There are three conditions. First, stable equilibrium, next unstable, then neutral. If there is stable equilibrium, then metacenter is above the center of gravity. If unstable, metacenter is below the center of gravity. And if neutral, then metacenter and center of gravity lies at a same position or coincide with each other at same point. Stable, metacenter above, unstable, metacenter below, and neutral, metacenter coincides with the center of gravity. Okay. Then next condition, the stability of submerged bodies. Okay. First condition is related to stability of floating bodies. In floating bodies, stable, metacenter related, and in case of submerged, it is related to center of buoyancy. For stable equilibrium, the center of buoyancy is above the center of gravity. Then it is a stable equilibrium. Then next condition, unstable equilibrium, center of buoyancy is below the center of gravity, then unstable equilibrium. In neutral, the center of buoyancy is coincides the center of gravity. Okay, so these are the three conditions related to the submerged body, stability of submerged body. In case of stability of floating body, there are three conditions. First is stable, second unstable, third is neutral. In case of floating body, we consider metacenter. If metacenter is above the center of gravity, then stable equilibrium. If metacenter is below the center of gravity, then unstable equilibrium. Is metacenter coincides with the center of gravity, then neutral equilibrium. And in case of stability of submerged body, first condition is stable equilibrium. In that, the center of buoyancy is above the center of gravity. In case of unstable equilibrium, center of buoyancy is below the center of gravity. And in case of neutral equilibrium, the center of gravity coincides with the center of buoyancy. So this is the question number 9. In the stability of floating bodies, the stable equilibrium is attained if the metacenter M point lies above the center of gravity. So option first is correct here. Then next, question number 10, and this is the important question. So specific gravity is defined as the ratio of mass of solid to the mass of equal volume. Mass of solid to mass of equal volume of water at 4 degrees Celsius. So option D is correct. So as usual, ये दोनों क्वेश्चंस आपके लिए है. इन दोनों क्वेश्चंस का जो भी सही आंसर होगा वो आप कमेंट सेक्शन में आंसर कर सकते हो. और ये और एक चीज़ मुझे आप सबसे पूछनी है कि जो ये मैं सीरीज बना रही हूँ वो बीएमसी प्रैक्टिस क्वेश्चंस की, तो ये सीरीज ही मैं कंटिन्यू करूँ या फिर कुछ और हम कर सकते हैं इसमें? मतलब मुझे ये लग रहा है कि हम क्या कर सकते हैं कि एक लेक्चर हम शॉर्ट नोट्स का ले लेते हैं। मतलब जो शॉर्ट नोट्स है किसी भी सब्जेक्ट की ले लो जो बीएमसी के सिलेबस का है, वो शॉर्ट नोट्स हम कंटिन्यू करेंगे। वो पूरे शॉर्ट नोट्स अगर कंप्लीट हो गए तो उसी सब्जेक्ट के एमसीक्यू जो है या फिर क्वेश्चंस है वो हम लेंगे। फिर हम सेकंड सब्जेक्ट लेंगे, उसके शॉर्ट नोट्स और फिर उसके एमसीक्यू। इस तरीके से हम कर सकते हैं। या फिर एक पूरा सब्जेक्ट हम कंप्लीट ले सकते हैं, पर उसके लिए मुझे लगता है उतना टाइम नहीं है हमारे पास बीएमसी के लिए। तो शॉर्ट नोट्स बेटर रहेगा। पर आप सजेस्ट कर सकते हो कि किस तरीके का वीडियो आपको चाहिए या फिर जो ये सीरीज है वही हम कंटिन्यू करें। तो जो अगला वेनसडे है, वेनसडे पर मैं नेक्स्ट वीडियो पोस्ट करूंगी। उससे पहले आप कमेंट सेक्शन में बता सकते हो कि ये वीडियो मैं कंटिन्यू करूँ या फिर कुछ और कर सकते हैं। वो सजेशन या फिर जो आपको चाहिए, जिस तरीके के वीडियो आपको चाहिए, जिस तरीके के वीडियो आपको बीएमसी के लिए हेल्पफुल होंगे, उस तरीके के वीडियो पोस्ट मैं कर सकती हूँ। और उसके लिए आपको सिर्फ कमेंट सेक्शन में कमेंट करना है कि किस तरीके के वीडियो आपको चाहिए, तो वो आप पोस्ट करें। और इन दोनों क्वेश्चंस का आंसर जो करेक्ट है वो भी पोस्ट करें। थैंक यू।